IGCSE Computer Science, Syllabus Statement 1.1.2c, Convert positive hexadecimal integers to and from decimal. So, you've done conversion before with decimal and binary. With hexadecimal, it's sort of the same concept, but it's a little bit different, of course, because we're working with base 16 instead of base 2, so we're going to need to do certain things a bit differently. Now, hexadecimal to decimal is harder than hexadecimal to binary, which we will cover in the next video. So, yeah, let's get to it. So, just remind ourselves of this table, and we have to remember these letters as well, corresponding to the decimal value. So, here we've got a sort of hexadecimal table, basically showing you each column represents a hexadecimal digit. So, yeah, we'll look into that soon, and I'll show you what I mean by all of this. It's sort of like the decimal binary thing we had in the first video, I think, first, probably both, but it'll all make sense. So, hexadecimal to decimal. So let's, for example, convert DE3 to decimal. So the way to do this is to multiply each digit by its value. And again, we have this table here, just like the previous slide. This is what I was talking about. So we can plug in hexadecimal values below these, and then we can multiply them. So remember that D is 13 and E is 14. So we get 256 times 13 plus 16 times 14 plus 1 times 3. So we basically multiply the columns and then sum them up. So we get 3,328 plus 224 plus 3, which makes 3,555. Now, I don't think that the exam is going to give you really large values like DE3. Maybe 2 digits, maybe perhaps 3, but I don't know if they're going to do 4. But because it's a non-calculator test, so I can't imagine anyone asking you to convert really large numbers like that, unless of course they think you're really. All right. So let's take a look at another example. So 2b 3f to decimal. So again, multiply each digit by its value. So it's 4,096 times 2, so on. And remember that b is 11 and f is 15. So again, we sum them up. And then we get the value 11,071. So decimal to hexadecimal, well, the way I like to do it, because the other way is a bit tricky, the way I like to do it is to use the division by 16 method. So if we were to convert 200 to hexadecimal, as in the decimal value 200 to hex, so we'd have our table here, and we basically divide the number and then get the remainder of the division. So 200 divided by 16 would give us 12, remainder 8, and 12 divided by 16 would give us 0, remainder 12. So what we do is read the values from bottom to top. So we remember that 12 is C, so it would be C8. It's just like that. Now this is similar to the division by 2 method with binary and decimal, in case you didn't know that. And again, we also read the remainder from bottom to top, and this is the same thing. So let's look at another example. So 3,294 to hexadecimal. So again, set up your table. 3,294 divided by 16 gives us 205, remainder 14. Dividing that would give us 12, remainder 13, as in 205 divided by 16 would give us 12, remainder 13. And then, of course, 12 divided by 16 is 0, remainder 12. We read the values from bottom to top. So remember that 14 is E, 13 is D, and 12 is C. So 3,294 is CDE.